Good evening, and thank you very much for watching another episode of Studying Like an Asian. Today, I would like to talk about this really nasty HSC dot point on you carrying out a first-hand investigation on analysis of projectile motion, finding out things such as range, initial speed, final velocity, and that sort of things of a projectile motion using computer analysis. Now, a lot of people have difficulty articulate this dot point either because they've never done it or they watch a friend over their shoulder trying to figure out how to work it. So therefore, this tutorial is there to actually give you some more in-depth information about how this particular analysis works using a software, making sure that you gain a little bit more confidence running the computer analysis. Without further ado, let's get into it. The software that we'll be using tonight would be Tracker. Now, you don't have to use this particular software. It's just that I'm Asian. I like to use freeware out there. And on top of that, it works for both iOS and also Windows 7 and 8. But before you install, just make sure that you have privilege to install Java and run it on your computer. And moreover, please make sure that you have the Sugo encoding codecs for your computer. If you don't have it, that's fine. When you start running or the installation and such, right, it will ask for it and actually ask for permissions and such. So therefore, if that has to be done in a school library or maybe a school computer as such, just make sure the IT department understand that kind of requirement. Now, pitfall number 2 for installation, yeah, I know it's a bit tricky. You need to make sure that in the middle of the installation, when this screen pops up, it will ask you, would you like to include the video and experiment suite? You click yes, all right? Otherwise, you will be missing the video for this particular tutorial. Now, in the worst case scenario, if you don't have that, that's fine, all right? If you look at the description section below, all right, there's another link to my Gmail Drive up there, or should I say Google Drive, sorry, all right, to download another copy just in case you don't have it. Anyway, pretend that everything is going right. Hopefully it should be. All right, and you should be able to open up the software like that. And to get started, we will be opening a file. And under the experiments folder, you should be able to find portos.trk. So that's the file that we'll be looking at and analyzing your projectile motion today. Okay, so let's go through some basic control on this particular software out here. On your toolbar there, the one that actually will interest you in any form of manner is basically these 5 buttons out here. The first one up there, which shows you the trajectory of the projectile. The second one, it's basically the capture of the projectile. And you say, well, hang on a second, where does that come from? I'll just rewind the video all the way from the beginning and go. See that? So basically, when you think about this, right, a video being captured on your webcam basically is just a series of still shots, but they capture very rapidly. So your computer, when it's trying to place back at you, they just play back a whole bunch of still shots very rapidly and give you the illusion that you're actually watching something that's moving, but in truth, it's just still shots that are being run through your face very rapidly. So if you actually look at the individual still shots, these are the position of the ball across the dark background. In case you did not download or just say install the video library packages and such, and if you have to do this manually, you need to make sure that your ball and your background has a very strong contrast. In this case, white ball versus black background. Now, weird thing number 2 is this strange looking stick in the middle. All right, this is what we call a yardstick. Now, when you think about this, right, this software can produce things such as displacement and speed, acceleration in metric units, basically in meters per se. All right. So you will say, hang on a second. If you actually do a video, your video actually measure distance based on pixels, and how would that actually convert that into meters? And hence, that's why you will need this little thing up there called the yardstick. It's physically speaking an object that you know it's distant, or just say length in real life. All right, for example, from here to here, you know this is 5 centimeter. You plug it in and put it back into the coordinate system in this software out there and let it know about this particular what you call distance out there, and that's how they actually calculate the other quantities such as speeds, etc. Now, in this tutorial, it's already done for you. You will not be asked in the HSC to say, well, how do you actually put in the yardstick, etc. That's not needed, but rather how you actually analyze the projectile motion using the software. Alright, without further ado, let's look into what you can actually analyze from the software now. On the right hand side, you see a plotting tool as well as a table tool up there. In case you didn't actually see a plot and you see some weird things out there in the first place, all you really have to do is click on this icon up there and change the property, alright, from table to plot or whatever it is, alright. Now, your task for this particular computer analysis, in case you actually didn't have it, you can actually again download it underneath, alright, in my Google Drive up there with the documents and such. So basically, all it's asking is basically you actually trying to generate a plot from the video, and using this plot up there, calculate, or I should say determine the initial speed or maybe final velocity, range, acceleration due to gravity and such. But the thing is, I need you to do a screen grab first, alright? Dump it into your tutorial document up there to show that you actually did, got the right plot, and then using that particular plot up there to identify features of the graph that actually helps you identify things such as speed and accelerations and such. Anyway, when you got this plot up there, you say, well, hang on a second, that's not the y-axis I want to analyze. I want to analyze something else. Easy. All you have to do is literally click on the label of each of the axes, and you can change it according to what's available in the menu. Now, people would say that's like a year 7 challenge. I want something a little bit more, and of course I will give it to you. So instead of just finding out those quantity you've been asked, alright, I want you to give me multiple, at least two different ways in which you can find out acceleration or maybe horizontal speed and such using the graph presented, how can I say, in the software out there. So to do so, you may or may not know that there's actually an analysis button up there, and basically it will go through more of these data up there with more details. For example, it will provide you number one, slope of the lines, alright, and from there I hope you can be able to work out things such as accelerations and such. But you know what, if you actually think about data seriously, not every single point sits on this line of best fit perfectly. You can actually find out slope, you know what, on individual point. See that the yellow, what you call boxes down there? Alright, it will tells you, alright, the slope at that particular data point, what that may be. And you will say, well, big deal, I mean, why would you actually need that? Because if you are awfully curious, what you will find out is, should I change this to acceleration in the y direction? Whoa. Alright, that's a little bit unexpected. Now, that's part of your challenge question. You need to find ways to explain why this is so different from your anticipated value. And as always, thank you for watching, and hopefully you become a more professional Asian in your upcoming HSC exam. See ya.